Good morning. Good morning, students. Good morning. Okay. So still students have to come. Only I can see 19. Yes, Dikshit. Okay. So can anyone what we have discussed in the last class? Hmm? Can anyone what we had discussed in the last class? Okay, quantum mechanic model. Okay, so we started with the quantum mechanic model after solving the some of the problems related to Heisenberg's principle, right? So that's where we have started with quantum mechanic model. ಹಾಗಾದರೆ when it comes to quantum mechanic model, absolutely correct, both of you. Now with respect to this, we have discussed about some of the terminology, right? So some of the terminology, which is that is wave number, right? So that is wave number. Symbolically we can represent it as psi. So that's where we have the wave number, right? Now ಹಾಗಾದರೆ what do you mean by wave number? So wave number is going to deal with the okay Suchitra madam. Okay, so what do you mean by wave number? Wave number is related to wave property of the electron with respect to its energy and with respect to its wave property, that means position. Okay, wave number deals with the position and energy of the electron, where it deals with the wave nature of the electron. That's where we have the wave number. Then we had wave number square, which can be written like this, or we can write like this also, right? Psi square, that is nothing but psi square. Yes, Stefan, that's what we are going to discuss. So psi square is nothing but a region or area where probability of finding the electron is high around the nucleus. So what is psi square? Once again it is related to wave nature of the electron only. Now psi square talks about a region, probable region around the nucleus where finding the electron is very high. So that's what psi square. Got my point? So psi square talks about region. What is psi square? Psi square is nothing but square of the wave number. Okay? So that's square. When I am talking about psi square, we are dealing with the region. When we are talking about the wave number, we are dealing with the electron. All of you have understood? So wave number deals with the position and energy of the electron, and psi square talks about the region around the nucleus where finding the electron will be very high. All of you have understood? Only 1 minute, sorry. Hello. ಹೇಳಿ ಸರ್. ಹಾಂ, ಓ 9 ಒಳಗಡೆ ಕಷ್ಟ ಸರ್. 9:15 ಇರ್ತೇನೆ ಬಿಡಿ, ಅಲ್ಲಿ 9:15 ಅಲ್ಲಿ ಇರ್ತೇನೆ. ಓಕೆ ಸರ್, ಓಕೆ. ಹಾಂ, ಎಸ್ ಸರ್, ನಾನು ಬೈ 9:15 ಅಲ್ಲಿ ಇರ್ತೇನೆ. ಓಕೆ ಸರ್, ಓಕೆ. sorry, it was a bit urgent. Okay, fine. So psi square, it is related to region where finding the electron will be very high. So that's where we have the psi square. Any doubts in this? Psi and psi square, 1 mark question you can expect. Any doubts with regard to this? Now we are going to deal with very important concept, that is quantum numbers. Please remember from this particular topic, Bohr's atomic model, hydrogen spectra, limitations of Bohr's atomic model, Rutherford's atomic model, then quantum numbers. Very repeatedly they have asked the question on this. Okay na? So that's where we have the quantum numbers. So in the last class, means yesterday, we have discussed briefly about the quantum numbers. Fine, we have discussed briefly about the quantum numbers. So that's where we have the quantum numbers. So what do you mean by quantum numbers? So quantum numbers is related to electrons, position of the electrons, which deals with the explanation about the position of electrons. Or I can tell that significance of quantum number is, if I define the 4 quantum numbers for an electron, that means I am locating the electron around the nucleus. Got my point? Yes, Pooja. So that's where we have the quantum numbers. So in that, first one we are going to deal is principal quantum number. First one we are going to deal is principal quantum number. Okay. Now, when I am talking about principal quantum numbers, which we have already discussed, this term we have come across during the Bohr's atomic model, and I told this particular terminology we are going to discuss once again in quantum mechanic model also. That's where we have the principal quantum number. Okay. Now, when I am talking about the atom, this is what we used to draw the picture of the atom, and all the circles, they talks about energy level. All of you will agree? Pooja, we will come to that. First we will discuss one by one. So yesterday, yes, as you told, yesterday already I have mentioned all the 4 quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. Okay? So in that, one by one I am going to explain now. Fine? Now when it comes to principal quantum number, to understand that, once again we have to go to Bohr's atomic model. Right? So where we have the nucleus and electrons will be revolving around the nucleus, and that is called as energy level, or according to Bohr's atomic model, that would have been called as orbit. Now we are not going to use the word orbit here. Okay? So that's where we have the energy level, where electrons will be present around the nucleus. Now that energy level, if you remember, we used to represent as, for example, this one we used to write it as n is equal to 1, this one n is equal to 2, and this one n is equal to 3. That means we are talking about n, that is principal quantum number. That is nothing but principal quantum number, if you recollect. So that's where n is equal to 1, n is equal to 2, and n is equal to 3, which is nothing but energy level. In the name itself it is there. Principal quantum number is going to talk about the energy level or energy of the electron. It talks about energy level. Okay? So it deals with the energy level. If I know the principal quantum number, that means I know the energy involved. Now, please remember, as the energy level or principal quantum number value is getting increased, that means energy is also getting increased. As the principal quantum number value is getting increased, energy is also getting increased. Now it's a very simple concept. Some students, they will get confused that, sir, an electron which is present near to the nucleus, they should be having high nuclear force acting on them compared to electrons which are present bit far from the nucleus. That's what the question. Okay? See, for example, I will make this one as 1, 2 and 3. According to many students, they think that electron 1 and 2, they will feel same amount of nuclear force and it will be bit high compared to electron 3. All of you will agree? So that means when I am talking about nuclear force, E1 and E2, they are having equal amount of nuclear force acting on them and it will be far greater than that of the electron 3. It will be far greater than that of the electron 3. All of you are understanding? That is related to nuclear force, amount of nuclear force acting on them. Then it is fine. With respect to nuclear force, we are right. Electron 1 and 2 will have high nuclear force compared to electron 3, which will be acting on them. Absolutely correct. No doubt. But still, why we are considering energy of energy level 3 will be higher compared to energy of energy level 2 compared to energy of energy level 1. So why this confusion is there, sir? Although nuclear force is more with respect to nearby one. So further the electrons greater the nuclear pull. So that is not the correct answer, Stefan. If I take a magnet, I have a iron nail here. Okay, I will hold like this. This one, horizontal one is a magnet and vertical one is a electron iron nail. Now I have a iron nail here and I have a iron nail here. Where magnetic force will be more? Anyone? First position, second position. Where magnetic force will be more? At position first or position 2? You can just mention 1 or 2. That's all. Okay? Any one of you? Rohan, I will come to that. I have a magnet and I have the iron nail. Yes. Now you got my point. Yes. Naturally at position 1, there will be more magnetic force on the iron nail compared to iron nail which has been placed at position 2 because it is bit far from the magnetic field. Right? Now same way, if I take the nuclear force, of course an electron which is present here will be feeling more nuclear force compared to electron present which is present here at position 2. Same as that of iron nail and magnet, I am comparing with electron and nucleus. All of you have understood? So with respect to nuclear force, yes, this is absolutely correct. Correct. What we are assuming here is electrons were here and it got redistributed. Okay. So some electron which will fit here in this region, they will present here. Some electron they will move here. Some electron they will move here. Some electron they will move here. Like that they will be redistributed. Now if you observe it carefully, I have a iron nail, I have a magnet. Now I have pulled this iron nail from the magnet to here. We will imagine it was attached to surface of the magnet. I have pulled this particular iron nail to here. That means I have applied some force or energy. All of you will agree? Now once again I will pull this iron nail here. Once again I have applied the energy. All of you will understand? Now once again I will apply some energy to pull this iron nail to here. So that means each step I am applying the energy. Energy 1, energy 2, energy 3. Now you got the point. So energy 1, energy 2, energy 3. So that means that's where I have a nucleus and electron was present here and a nuclear force was acting on them. Now I will push this electron. Now it will be at position 2. This was at position 1. Once again I have pulled that one to position 2. Now once again I will pull that one to position 3. So that means when I am talking about electron position 3, I have applied E1, E2 and E3. So total energy involved will be E1 plus E2 plus E3. But if I take electron at position 2, then the total energy involved will be E1 plus E2. Got my point? So now can you understand why as the principal quantum number value increases, energy will increase? Why we have assumed? This is the reason. All of you have got the point? So therefore, as the electron will move away from the nucleus, nuclear force is going to decrease, no doubt. But the problem here is those electrons have moved far away by applying the energy from the nucleus. So therefore, that total energy we are considering. So therefore, as the number increases, n value increases, energy also increases. That's what we will assume. So energy level 1 will be of less energy compared to energy level 2. Energy level 2 will be of less energy compared to energy level 3. So that's where, if possible, electrons will try to fit into lower energy state. Electrons will try to fit into low energy state. But there is a limitation. Say for example, I have one chair. In that one chair, one person can sit comfortably. But if I ask two students to occupy that particular chair, the first question from student is, we can't focus to the class, sir. We are uncomfortable. We want one person in one chair only. That will be the point which will be raised by the student, which is correct. Same way, although this is the one which is of lower energy condition where electron will be stable, but since there is a shortage of space, whatever extra electrons will be there, it will move to next energy level. It will occupy there first. Once it is occupied, if still more electrons are there, then it will move to the next energy level. So that means first it will fill the low energy one, then it will go to higher energy, then it will go to higher energy due to the lack of space. Now you got my point? You should not forget electron repulsion, because negative charge, they will repel each other. Okay? So whether you got my point? Why there is an increase in principal quantum number? Why there should be increase in energy of that particular electron? Whether you got the point? All of you have understood? Okay, done. So that's where principal quantum number, it majorly talks about energy involved. It majorly talks about energy of the electron. Okay? So that's where Rohan is there at present in Mysore. Where Rohan is there in Mysore. That's what. And energy level 1 electron is there. E1 is present at energy level 1. When I mention E1 is present at n is equal to 1, that means I am telling that E1 is present at energy level 1. Further, we have to give the information to exact location of the electron. Okay, so fine. So where are you then? Oh, you are not in Mysore. I thought you are in Mysore. Okay, that's fine. So in that case, I will tell Rohan is in Karnataka. Okay, but where in Karnataka? In Mysore? Or in which place of Karnataka Rohan is there? Oh, Hubli. Very good. Near to my place. I am from Sirsi. Okay. Hubli. Very good. So that's where Rohan is in Karnataka. But in Karnataka where? In Karnataka, in Hubli. That's what we have to search now. We know in Karnataka, but where in Karnataka? In Hubli, but that one we have to search. Okay? So same logic is applicable. Electron 1, where it is? It is present in energy level 1. Further details we have to give. Where exactly electron 1 is located. All of you have understood? So that's where we have the principal quantum numbers, which talks about energy involved with respect to electron. Energy level for an electron. That's where principal quantum number talks about. All of you have understood? So therefore, last one statement we can give. Energy level. As increase in the energy level will increase the energy. Will increase the energy involved. Okay? As there is increase in the energy level, will increase the energy. That means, as there is increase in the principal quantum number, it is going to increase the energy. Any doubt in this, with respect to principal quantum number? If you don't have any doubt, shall we move to the next one? Shall I move to the next one then? Okay, let it be here only. Okay, we will move to the next. That is azimuthal quantum number. Azimuthal quantum number. Okay, so that talks about small l. Azimuthal quantum number, that talks about small l. Okay, now azimuthal quantum number can also be called as subsidiary quantum number. As I told yesterday, it can also be called as subsidiary quantum number. Okay, now as we have discussed, n and all we have discussed, right? This is n3, this is E3, or this is n is equal to 2, and this is n is equal to 1, right? So that's what we know. Now, this one can be called as shells. They can be called as shells, which will be represented by principal quantum number. Shells will be represented by principal quantum number. Now comes the azimuthal quantum number, which talks about subshells. It talks about subshells. Okay? It talks about the subshells. Same way, it talks about shapes of the orbitals. It talks about the shapes of the orbitals. All of you have got my point. So that's where we have the subshells and shapes of the orbitals. Which one? Azimuthal quantum number. Right? See, for example, now we know that Rohan is in Hubli. I thought he was in Mysore, but he is in Hubli. But in Hubli where? Vidyanagar, Vishweshwar Nagar, Keshwapur, so many places are there. So where he is located? Okay, in which area? Hubli is a broad, big city it is. Okay, but in that big city, where it is exactly, where he is exactly, in which area he is located? That's what we are searching now. Same logic is applicable for electron here. Yes, E1 is present in shell number 1. Okay, or principal quantum number 1. But in energy level 1, where exactly it is located? So that's where each shell will have their own subshells, combination of subshells. So in which subshell they are present? Okay, all of you have understood? So that's where we will be using the word orbitals. So that's where we will be using the word orbitals. Okay, so what do you mean by orbitals? Orbitals nothing but which can be explained by using psi square. That's what I told. A region around the nucleus where probability of electron is high. Finding the probability of electron is very high. So that's where we have the orbitals. All of you have understood? So which can be represented, which will give rise to subshells due to the different shapes. All of you have understood? Say for example, we have the S subshell. We have the S subshell. S subshell will have the spherical shape. S subshell will have the spherical shape. Okay? Now, on what basis we are thinking that it is having spherical shape like a cricket ball? That is because of the probability of finding the electron around the nucleus in that particular region. See for example, I have the nucleus. Okay? So this is where I am finding probability of electron high. Whatever dots I have written, that's where I can find the probability of electron high. Right? Since I am writing it on the board, I am showing it in 2 dimensions. 3 dimension means it is actually spherical. But here it looks like circle. It's not a circle, it is a spherical. Please remember, don't ever write it is having circle shape. Okay? So it should be spherical shape. Fine? 3D. So that's where we have the S subshell. Now I can tell that this is 1S subshell. This is nothing but 1S subshell. That means we are talking about E1, which is present at 1S. 1 stands for principal quantum number, n is equal to 1. Since we are dealing with E1, so here 1 talks about principal quantum number and S talks about azimuthal quantum number. S talks about azimuthal quantum numbers. All of you have understood? So what is that shape? That shape is a spherical shape because we are dealing with the S subshell. All of you have understood? Now please remember, each energy level will have the S subshell. Each energy level, it starts from energy level 1, right? So 1, 2, 3, whatever the energy level will be there, all those energy level will be having S subshell. But only thing here is that number will vary. When it comes in energy level 1, it is called as 1S. If it is with respect to energy level 2, then it will be called as 2S. If it is with respect to energy level 3, then it is called as 3S. So that's where we can have the different S subshell with different principal quantum number value. But shape will remain same. Shape will remain same. But only thing is 2S will be much more larger compared to 1S and 3S will be much more larger compared to 2S. All of you have understood? Only thing is size is going to vary because principal quantum number is getting changed. All of you have understood? Anyway, in detail all these things I am going to discuss when I will be talking about nodal region. During that time, we are going to discuss once again. But for timing you should remember that if this is 1S, this will be 2S, this will be 3S, like that size of the sphere is going to increase. Diameter is going to increase. Diameter in the sense from the center, that is from the nucleus we have to consider. So diameter is going to increase. So size of this subshell is going to decided by anyone. Size of this subshell is going to decided by any one of you. Shape will remain same. Whichever subshell, S subshell you take from any of the energy level, it will be spherical in shape only. But size will vary. So size of a S subshell is going to decided by anyone? Yes, it will be decided by n value, that is principal quantum number. All of you got my point? Chidwan, absolutely correct. It will be decided by not shape. Okay? So shape is spherical shape only, but size is going to decided by principal quantum number. Okay, so I will make a point here. L subshell just talks about shapes, but the size of the subshell decided by n value. What is that n value? N value is nothing but principal quantum number value. All of you have understood? So that's what we can see. All of them, they are spherical. Only thing is 1s is smaller compared to 2s. 2s is smaller compared to 3s. All of you have understood? Okay, that's why we have the azimuthal quantum number, which is represented by small l. Okay? Any doubts in this explanation? So it talks about subshell and shape of the subshell or orbitals. Okay? Any doubt? Any doubt with respect to this explanation? In that case, shall we move to the next one? Okay? Fine. So same way, if I move to the P subshell, anyway, detailed structure we are going to discuss, don't worry, when it comes to P subshell, because even it talks about subshell, right? We have S subshell, P subshell. Don't ever write P shell, it should be subshell. Okay? So it will be having dumbbell shape. Okay, na? It will be having dumbbell shaped structure. So which one? P subshell. It will be having dumbbell shaped structure. So that's where, by considering this one as a nucleus, so that's where we can have the dumbbell shaped structure. Naturally, if it is a 2p1, why sir? Why we have not written 1p? I will give the answer for that. Because P subshell will not be there at energy level 1. I will make a point. Energy level 1 does not have P subshell. Energy level 1 does not have P subshell. In the beginning, for S subshell I told, all the energy level from 1 to any energy level, all of them they will be having S subshell I told. But same thing is not applicable for all the subshell. See, for example, P subshell, it will present from energy level 2 onwards, but not at energy level 1. That one you have to remember, and I will give the answer. What is that reason? Okay, na? So that's why energy level 1 does not have P subshell. So don't ever write 1P, which is absolutely wrong. So you can write 2P, 3P, 4P, 5P, whatever it is, but not 1P. Okay? So if it is 2P, if I want to talk about 3P naturally it should be larger than that of the 2P. 4P, which will be much more larger than that of the 3P. So that's what, same as that of the S subshell. Here also, size of the subshell is going to increase depending on the N value. We should start from 2P. Yes, Rohan, absolutely correct. We have to start from 2P. It's not like S subshell. We have to start from 2P. Okay? So that's where I have the 3P. 2P is smaller than that of the 3P with respect to the size. Shape, dumbbell shape only. All of you have understood? So once again, here size is going to be decided by N value, same as that of the S subshell. All of you have understood? Any doubts with respect to this? Any doubts? Okay? ಹಾಗಾದ್ರೆ we will move to the next one. We have total 4 types of subshell. Very commonly we can see 4 types of subshell. S and P, 2 are over. Now we have D1. Now we have D. Now D subshell, it is having double dumbbell shape. It is having double dumbbell shape. Double dumbbell shaped structure. Okay. Now, if this is the nucleus, so it will be having double dumbbell. That's where we have the double dumbbell, like a chromosomes, like a chromosome, diploid condition, chromosomes, biology students, right? So same as that of here, right? So that's where we have the centromere. It's not centromere, please. It's the nucleus. So that's where we have the double dumbbell shaped structure with respect to D subshell. Okay, with respect to D subshell. Now, I will tell that D subshell will start from n is equal to 3. That means 1 and 2 does not have D subshell. 1 and 2 does not have D subshell. That means 1D, it's not there. 2D, it is not there. 3D, it is there. So that's where we have the important point. Don't ever write 2D. Okay? Same as that on the P subshell, where 1P is not there. Same when it comes to D subshell, 1D, 2D is not there. It will start from energy level 3. This one you should remember. Okay? See, for example, this is one of the D subshell. Okay? 3D. If I want to go with 4D, naturally, it will be much more larger. It will be much more larger compared to 3D. It will be much more larger compared to 3D. Hagadre, once again, when it comes to size of the D subshell, who is going to decide? Once again, n value. Once again, n value is going to decide. 3 and 4. They are the n value. They are going to decide size of the D subshell, which is having double dumbbell shape. Here also it is double dumbbell shape. Here also it is double dumbbell shape. Shape is not going to get changed. It will remain same. But only thing here is the size is going to increase. Only thing here is the size is going to increase. All of you have understood? Any doubts? So this is with respect to D subshell. This is with respect to D subshell. When it comes to last one, F subshell. When it comes to F subshell, which shape and all it is not there for you people. Okay. So when it comes to F subshell, it will be having complex type of structure or shape. It will be having complex type of shape. And don't worry, shape is not there for you people. Okay? Stephen, yes, F subshell will start from 4. Very good. It will be 4F. The beginning, smallest one will be 4F. That means at 1, 2 and 3, they don't have F subshell. We don't have 1F, 2F, 3F. It is wrong. Absolutely wrong. So it will be 4F onwards we will be having. 4F onwards we will be having. Okay. So naturally 4F will be of smaller size compared to 5F. 5F will be smaller compared to 6F. So what I mean to tell you is if I take this size, so 4F will be smaller compared to 5F. 5F will be smaller compared to 6F. That's how size is going to increase depending on the n value. N is equal to 4, n is equal to 5, n is equal to 6. But we don't have n is equal to 1, n is equal to 2, n is equal to 3 for F subshell.
3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3 subshell. 3
All of you have understood? So this is what you have to remember. What is that structure called as? Complex type of structure. Okay? But when it comes to S subshell, it was spherical. When it comes to D subshell, it was double dumbbell. P subshell, it was dumbbell. And F subshell, it will be complex type of structure. All of you have understood? 1 mark question you can expect with regard to shape of the orbitals. Okay? Or 2 marks question to draw the shape of P subshells. Then you have to draw the picture. Anyway, those things we are going to discuss. But for this one you have understood? Any doubts? So in that case, now listen to me carefully. For a given n value, for a given n value, what is that n value? Principal quantum number. For a given n value, L value will be 0 to n minus 1. 0 to n minus 1. That's what you have to remember. So with respect to L value, it will be decided by n value itself. L value is dependent on, sir, all the subshells are there in the same single atom. Yes, depending on the number of atoms, it is available in all the atoms. Only thing here is at energy level 1, only S subshell. At energy level 2, S and P. At energy level 3, SPD. Okay, fine. I will draw that one so that you can understand. Okay, the question was whether the same atom will have all these subshells. Yes, of course, definitely. It will be there. Wherever, whichever energy level is available, depending on that, so many orbitals will be there, or subshells will be there. See, for example, this can be any atom. We don't know. Okay? So this can be any atom. Since n is equal to 1, available subshell will be S subshell. Okay? Since n is equal to 2, available subshell will be S and P. Since n is equal to 3, available subshell will be SPD. Since n is equal to 4, available subshell will be SPDF. Okay? SPDF. For 5, SPDFG we can write. But anyway, G will not come across. So this is where we have the SPDF. Yes, this is where we have the electronic configuration. We have to write. Chidwan, is it 14 means what? Okay, I will come to that. Yes, I will come to that. Okay, I will come to that. How many electrons will be there in each subshell? I will come to that. Yes, they are related to magnetic quantum number, but shape will be related to azimuthal quantum number. How many orbitals in a subshell? It will be related to magnetic quantum number. I will come to that. So before going for that one, now whether I am clear? Single atom, same atom will have all these subshells. Okay? But depending on the energy level. All of you have understood? Fine. So in that case, for a given n value, L value will be 0 to n minus 1. 0 to n minus 1. If that is the case, if n value is equal to 1, okay? So what will be the L value? What will be the L value? If n value is equal to 1, what will be the L value? Because the L value ranges from 0 to n minus 1. So what will be the L value? These are important. For competitive exams, it will help you out. So for a n is equal to 1, what will be the L value? Anyone? Just you can mention the value. Yes, very good, very good. So it should be 0. It should be 0 because n minus 1, that means 1 minus 1 is 0. L value will be 0. Okay? So now, if n value is equal to 2, what will be the L value? Now I can see. If n value is equal to 2, what are the L values? Okay, I think in that case you have not listened to me properly when I was pronouncing. In the first case, when I told n is equal to 1, what is the L value I told? But second time, n is equal to 2, what are L values I told? That means it cannot be one value, it should be two values. Right? So it should be two values. Yes or no? So that's where you should observe the English. Here singular I used, here plural I was using, values I told. Here I told value. So when n is equal to 2, so there can be two values, 0 and 1. Yes, Sanya, very good. It should be 0 and 1. Even others also they have written. Yes, it should be 0 and 1. It cannot be single value. It will be 0 and 1. Please remember, it is 0 to n minus 1. That means more than one value you can expect for a azimuthal quantum number. So therefore it will be 0 and 1. If n value is equal to 3, what are the values of L? If n value is equal to 3, what are the values of L? If n value is equal to 3, what are the values of L? Yes, now you got the point. Very good. So L value will be 0, 1 and 2. Very good. If n value is equal to 4, what are the L values then? All of you are absolutely correct. In that case, if n value is equal to 4, what are the L values? Yes, very good, very good. So that's where 0, 1, 2 and 3. So it cannot be equals to n value. It should be 1 less because n minus 1. Absolutely correct. All of you are right. Very good. So that's where energy level 1 we have S subshell. Energy level 2 we have S and P subshell. Energy level 3 we have SPD subshell. Energy level 4 we have S, P, D and F. Anyway, I'll stop here for n is equal to 4. So that's where we have the subshells available. Therefore, see here properly. So therefore, if you take S subshell, L will be considered as 0. If you take S subshell, L will be considered as 0. If I take P subshell, L will be considered as 1. L will be considered as 1. If I take D, L will be considered as 2. L will be considered as 2. So 0 S, 1 P, 2 D. So for F, what will be the one value of L? For F subshell, in that case, what will be the value of L? For S, L can be 0. For P, L will be 1. For D, L will be 2. What about F? L will be Puja. How come it is 4? It should be 3. So it should be 3 here. Observe it carefully. 0 is S. 1 is P. 2 is D. 3 is F. Right? So therefore, for F it will be 3. For F it will be 3. Very good. All of you are absolutely correct. So these things you should keep it in your mind. Because some of the questions will be based on this, even for board also, and even for competitive exams. Many times they have asked. Okay? Any doubts in this? All of you have understood? Okay? So what is that information? Even single question they can ask, not with regard to all the quantum numbers. They can ask, Explain about the azimuthal quantum numbers and its significance. Then you should tell what azimuthal quantum number talks about. Then you should talk about all these things. S is 0, P is 1, D is equal to 2, F is equal to 3. Everything you have to mention. Okay? And don't forget to mention this one. So that means L value will be decided by what? Any one of you. L value will be decided by what? At the end, another question I am asking. L value will be decided by what? Who is going to decide the value of L? All this explanation I have given. I want to see how much. Sanya, very good. L value will be decided by principal quantum number n minus 1, n. So, azimuthal quantum number value will be decided by principal quantum number. Okay? So, very good answer. That's where we have the azimuthal quantum number, which is also called as subsidiary quantum number, which talks about shape of the subshell. Which talks about the shape of the subshell and whose value will be decided by n, small n. Okay? So small n. It's not capital N. It should be small n. Fine? So that's why we have the azimuthal quantum number. Okay? So shall we move to the next one then? That is related to magnetic quantum number. Next one is magnetic quantum number. Okay, so small m and subscript small n. So magnetic quantum number. All of you have understood? So this is where magnetic quantum number is the one which gives the answer for splitting of the orbitals, splitting of the spectrum in the presence of magnetic field, electric field, which was not explained by Bohr's atomic model. Once again I will tell, magnetic quantum number is the explanation for splitting of the spectra, spectral lines in the presence of magnetic or electric field. That is Zeeman effect and Stark effect, which is explained by magnetic quantum number, which was not explained by Bohr's atomic model. All of you have understood? So that's where we have the magnetic quantum number, which talks about orientation, which talks about the orientation of orbitals. Orientation of orbitals, which deals with the orientation of orbitals. Okay? So orientation, shape, it will be dealt by azimuthal quantum number. How they will be oriented, that will be dealt by magnetic quantum number. That will be dealt by magnetic quantum number. That's where we have the orientation of the orbitals, which will be dealt by magnetic quantum number. And this is the one which gives the explanation about, Zeeman and Stark effect. Zeeman and Stark effect, which was not explained by Bohr's atomic model. Bohr's atomic model. All of you have understood? Okay? So it will give the information of orientation. This is the one which will give explanation about Zeeman and Stark effect. And this is the one which talks about number of orbitals. Number of orbitals in a given subshell. Number of orbitals in a given subshell. So that's where we have the magnetic quantum numbers, which talks about orientation of orbitals, which explain about the Zeeman and Stark effect, which talks about number of orbitals in a given subshell. All of you have understood? Okay. So what are orbitals? Orbitals are the area where probability of electron is high. Okay. So subshell is the one which will be having those orbitals in that. So that's where we have the number of orbitals in a given subshell will be decided by magnetic quantum number value. Okay. Now, very important formula is ml value. Value of ml is equal to 2l plus 1. Value of ml is equal to 2l plus 1. So it will be formula. You have to remember. In case of azimuthal quantum number, it was n 0 to n minus 1. But here it is 2l plus 1. It is 2l plus 1. You have to remember this formula. Okay. Now, if that is the case, if n is equal to 1, what was the L value? Anyone? What was the L value? 2l plus 1. Yes, but L should be small letter. Okay, L should be small letter. Okay, done. So, n is equal to 1. What is the L value? Anyone? Just now, few minutes back we have discussed. If n is equal to 1, what is the L value? L value is equal to, Yagnesh, why 3? If n is equal to 1, L value I am talking about. Not ml value, L value. It should be 0. In that case, what will be ml value? What will be ml value? Substitute the 0 here. ml value will be 2l plus 1. ml value will be, no, now I am talking about ml value. Why 3 people are writing? Why 3? 2 into 0. 2 into 0. It is 0. So total value will be 1. Total value of ml will be 1 because when L is equal to 0, that means 0 plus 1, that is 2l plus 1, that will be equal to 1. Okay, that will be equal to 1. All of you have understood? So that's where we have the ml value, which will be equal to, that value will be, total value will be 1. And that total value is 0. Total value is, don't get confused, 1, and that is 0. That is 0. All of you have understood? 0 is a value. So that value is 1. That is 0 is a value. So total value of ml will be 1. That is 0. Which is that value? That is 0. Okay. Now next one, if I explain, you will understand. If n is equal to 2, what is the L value? 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 It will be 0 and 1. Of course, it will be 0 and 1. Now I will consider this one. Okay. So that means 2 into L plus 1. That means 2 into 1 plus 1. So total value is 3. If I consider L value is 1, I will take L value as 1. 1 only, this value only I will take. 2 into 1 plus 1. That means total it is 3. Total it is 3. So therefore, ml value, total values are 3. Which are those total value 3? That will be, one is this one, another one is 0, and another one is minus 1. Or I will write, so this one has plus 1, this one has minus 1. So don't get confused. Once again I will repeat. So when n is equal to 2, L is having 0 and 1 value. So in that case, I will take 1. L value is equal to 1. So in that case, 2 into 1 plus 1. Total it is 3. So that means total ml value should be 3. Which are those 3 values? This is minus 1 as one value, 0 as another value, and plus 1 as another value. So that's where ml will be having 3 values, -1, 0, +1 when L is equal to 1. When L is equal to 0, ml will be having only single value, that is 0. All of you have understood? So if that is the case, if n is equal to 3, which are those values taken by L? If n is equal to 3, which are those values taken by L? Which are those values taken by L when n is equal to 3? So that will be 0, 1 and 2. Now I will take 2 as the L value. Okay, 2 into 2 plus 1. That means total value will be 5. 2 2s are 4 plus 1 5. So total values are 5 ml value. So which are those? It will be -2, -1, 0, +1, +2. 1, 2, 3, 4, 5. So total values are 5. So which are those? -2, -1, 0, +1, +2. All of you have understood? Okay. So anyway, I will stop here. Tomorrow once again, briefly I will explain after here. Then we will move to next one when n is equal to 4. Any doubts in this? Any doubt? Yeah, -2, -1, 1 and 2. Yes, absolutely correct. When n is equal to 2. 3. Okay, na? So any doubts in this? Okay, so no doubts. No doubts then? Okay. In that case, thank you. Thank you very much. Okay. So tomorrow once again we are going to discuss. But whatever I have discussed now, up to that you can practice. Okay. So thank you. Thank you very much. Take care. Okay. Bye. Okay. Thank you.